In this video, we will learn about limit at infinity. This will be a very intuitive definition, and we'll use just table of values to see what's going on. And then after that, we will learn few facts which will help us to find the limits we need for this course. Okay, let me start with very intuitive definition of limit at infinity. Well, limit at infinity means that x is growing either to large positive numbers or large negative numbers. So here we say, okay, let me start with function. Let f be a function defined on an interval like a to plus infinity for some a. So it is defined from a point on x axis. We say limit of f as x approaches to plus infinity is L. We write it as this one, limit of f of x as x approaches to plus infinity is L if the values of x, the values of f of x, values of the function get closer to L as the values of x grows to large and large values. In other words, what you just basically find the values as the value of x grows and see if the numbers of the values of f of x gets closer to number. Let me do one example. Use the table of values to find limit of f of I have a function for you, 1 over x here as x goes to plus infinity. Okay, so what should we do? X grows to positive infinity. It means that we should have a table at which the values of x grows. Well, let me start with 10, then 100, 1000, 10,000, and so on. Yes. And well, let's evaluate. 1 over 10 is 0.1. 1 over 100 is 0.01. 1 over 1000 is 0.001. 0.0001. And as you can see, this gets smaller and smaller. It gets very close to 0. And that is a fact, actually. 1 over x, limit of x going to plus infinity is 0. Well, similar to limit at plus infinity, one can define a remark. Similarly, one can define limit of f of x as x goes to negative infinity. Well, this time, as it suggests itself here, this time, for example, for 1 over x, we will only consider the very negative numbers. So if I start with x, so we will start with negative 10, negative 100, negative 1000. You see that this is getting more and more negative numbers, so this goes to negative infinity. And then values of f of x, 1 over negative 10 is negative 0.1, negative 0.01, negative 0.001, and so on. So this gets smaller, it is negative, but it gets closer and closer to 0. And that's in general the intuitive definition behind that, and this showed us that 1 over x as x goes to negative infinity is equal to 0. Well, these two things that we saw are actually special cases of very important fact. I will write all the facts we need here in the box. First one is that limit of not only 1 over x, but also when you have x to the power r, x goes to plus infinity is always 0 for any r positive. And similarly, you have limit of 1 over x to the power r as x goes to negative infinity is equal to 0. Well, you have to be careful for r positive and such that 1 over x to the power r is defined for negative. Defined for negative numbers. Well, for example, if it is 1 over x to the power half, there will be some problem. It's not defined on negative side of the x-axis. But if it is defined, the limit will be 0. Then the second fact is that all the laws of limit, work fine for limit at infinity. For limit at infinity. Remember what were the limit laws? For example, the sum, constant multiple, sum, difference, product, and quotient. Yes, all of them works. Quotient. And basically, this is the part of the what we learned, the limit as we learned before. Well, instead of an x approaching to number, this time x approaching to infinity. Let me do two examples to cover cases you see here. Well, example or applications of the facts mentioned above. Find the limits. Okay, first, limit of 2x minus 1 over x plus 3 as x goes to negative infinity, and limit of x squared minus 2x plus 4 over x cubed plus 3, and x goes to plus infinity. Okay, so when you look at these guys at the beginning, this is how you will deal with the rational function when you're trying to find the limit at infinity. Factor out the highest power from the numerator and denominator. So x, this is 2x over x minus 1 over x. That's how we factor the highest power. And then x here is x over x plus 3 over x as x goes to negative infinity. When you factor out the highest power, the power of x appears here, you can cancel. In this case, both of them are from the same power, so you can cancel both of them. Let me write this thing again as x goes to negative infinity. Here, see, 2 is the first, 1 over x is the second one. This is 1 plus 3 over x. Now, this guy here is that, well, limit of constant, always constant, minus limit of 1 over x. Remember the fact we said 1 over x to the power any positive number here, x to the power 1, goes to 0 as x goes to plus infinity or negative infinity. That's 0 over 1 plus this piece here again, the constant multiple rule, plus 1 over x times 0. So this will give you 3 times 0. And as you can see, this is just 2. What we did here is by factoring the highest power from the numerator and denominator, we basically turned this limit into nice limit that we can use the laws of limit. Okay, how about for this one? Okay, we can find the limit of this by factoring the highest power in the numerator and highest power in the denominator. Well, highest power in the numerator is x2, so we will get x2 over x2 minus 2x over x, and then plus 4 over x2 over x2 here. And this is x cubed over x cubed plus 3 over x cubed. Then factor cancel out as much as you can. We have limit of 1 over x as x goes to plus infinity times limit of here. This guy is 1 minus 2 over x. This is plus 4 over x squared. This guy here is 1 plus 3 over x cubed as x goes to plus infinity. Now, limit of the first part is just 0. That's the fact 1. 1 over x as x goes to plus infinity gives us 0 limit. Then, by product rule, we have this guy, the numerator is 1. This goes to 0. And this goes to 0. This guy is 1 and that guy goes to 0. So what we have here is 0 times 1 and that is equal to 0. This is the trick you need to know to be able to find the limit at infinity for rational function. Let me just write as a summary to find limit at infinity of rational functions. What you need to do is factor out the highest power of x in both numerator and denominator, and then use the laws of limit plus fact 1. Well, in the next video, we will get back to this and we will see what does this whole kind of computation mean for us when we are dealing for horizontal asymptotes.